Hey Pine Mountain, Miss Kohanic here. Now I know what you're thinking. I am sitting in the set of History in a Hoodie. But I don't see Miss Taylor here, I don't see Mr. Hoffmeister here, so I know what you guys are thinking. But you know, us in the science department, we are sick and tired of being shown up by social studies, so we put our heads together and we were like, let's do this ourselves. So, what we decided to do was give you the first ever episode of Science in a Sweater. Forget this history in a hoodie thing. It's going to be Science in a Sweater, brought to you today by Miss Kohanic. Now, before we get started, I wanted to introduce you to my co-host, Mr. Albert Einstein. I think this should be fine. We don't need those anyways. All right, so let's get started before Mr. Hoffmeister finds out I'm in here.
All right, guys, I'm going to attempt to go over a year's worth of content in 5 minutes. All right. These slides will be available for your teachers to go back over if you need to slow down and look at them more closely. But for the most part, the first unit that we went over this year, right in the beginning when you first came to us, was the structure and properties of matter. And so this included pure substances, states of matter, so moving from solid, liquid to gas and vice versa, chemical and physical properties, how you know if a chemical or physical change occurred, how atoms are structured, and chemical reactions. So with pure substances, that was really talking about your elements, so anything on the periodic table, and then compounds, which are 2 or more elements together. Mixtures are a little bit different because they can be separated by physical means, but it's 2 or more substances. They can be heterogeneous, which means the particles are not spread evenly throughout, and homogeneous, which means the particles are spread evenly throughout. We've done a lot of practice with states of matter during this prep course. So the states of matter with the most energy to the least amount of energy would be plasma, followed by gas, liquid, and then solid. Remember, adding more energy increases the motion of the particles, but if you take energy away, you decrease the motion. This is how you're going to change from the different states of matter. Chemical and physical properties and changes. So remember, chemical properties are anything like reactivity and combustibility, where physical properties are things like density, melting point, and boiling point. You can tell a physical change has occurred because it changes form, but it's not changing the chemical makeup of the element. Okay. But a physical change, things like tearing paper and stuff, or taking ice from a solid to liquid water, those are all physical changes. A chemical change, typically you'll see a formation of a gas or precipitate, so that's like the solid stuff that would be at the bottom, or some kind of change in color. Now, atoms are the smallest building block of everything. So they're made of a nucleus of protons, which are positive, and neutrons, which are neutral. Okay, they're in the center of the nucleus part, and then an orbit of electrons, which are negative around the nucleus. Chemical reactions. So remember balancing equations. So chemical reactions. I think this was everybody's favorite part with balancing equations. And so basically balancing equations is just a model to show you guys the law of conservation of matter, which states that matter cannot be created or destroyed. So what that's really just saying is the amount of products you have in a chemical reaction has to equal the amount of reactants, all right? So on each side of your chemical equation, they have to equal one another, and that's when you get into adding your coefficients and things like that. All right, energy. So we have kinetic and potential energy. Kinetic energy is the energy of motion, and it's related to the mass and velocity of the object. Potential energy is stored energy, and it is also related to mass, but also has the gravity coefficient or the gravity constant, which is 9.8 meters per second squared, plus the height. Since it's stored energy, the higher something is, the more energy that it's going to have. The transformation between kinetic and potential energy. So this really good example would be with roller coasters. So the higher the roller coaster climbs, the more potential energy it's building up. That built up energy then transforms in kinetic energy, which keeps the roller coaster in motion. So typically roller coasters don't have engines that keep them moving on the track. All of the energy that they need to be able to maneuver through the track is built up potential energy that they have stored and then transformed to kinetic. Energy types and transformations. I didn't list all the types of energy on there, so that would be something you guys should go back and look at. But the law of transformation of energy just says, again, energy cannot be created or destroyed. It changes forms. So examples would be like lighting a match, which is light to heat. It's putting that heat off with the fire, or turning on a light, which is electrical energy to light energy. Some of the other energies include nuclear energy, chemical energy, sound energy. Okay, and so those are all things I would go back and review. Transferring heat. So there's three types: conduction, convection, and radiation. So conduction, direct contact; convection, movement through currents; and then radiation is movement of atoms through space. Force, mass, and motion. So this unit was mostly on Newton's three laws. His first law says that an object at rest stays at rest, and an object in motion stays in motion unless acted on by an outside force. So typically it's going to be friction. That's why if you go bowling and you roll a bowling ball down the bowling lane, besides hitting the bowling pins at the end, there's going to be some friction between the ball and the lane. But that is one reason why they kind of oil it up, because it is reducing the friction. But pushing a rolly chair across the floor, all that kind of stuff, there's friction that goes with it. The second law says that the more force exerted on an object, the greater acceleration. So if you are at the park with friends and you are pushing a friend on a swing, it's going to put more effort for you to push a friend your age versus a child who's 4 or 5, because the mass isn't as great in a child who's younger. And then your third law: for every action, there is an equal and opposite reaction. So the force that you put in, there's a force that's exerted. Um, Inertia and mass, so that's kind of going back with the second law. So again, like I said, the heavier something is, the more force it takes to move the object. And remember, inertia is an object's tendency to resist a change in motion. And last, up at the top, speed, distance, velocity, and acceleration. So these are all related to each other, but speed is the time it takes for an object to move a certain distance. Velocity is actually speed, but giving direction to it. So, saying you're going 5 kilometers an hour north, you add a direction to it. And acceleration is any change in velocity. So if you change the speed, you either speed up or slow down, you change the direction, or you do both things. That's going to be a change in acceleration. Waves. You guys are working on this now, or just kind of finishing it up. So I'm going to go really quick through this since this is a current topic. So electromagnetic versus mechanical waves. So remember, electromagnetic waves do not need a medium to travel through. They can travel through medium, but they don't require it. But a mechanical wave does require a medium. You have transverse and longitudinal waves. They have different parts depending on the type of wave they are. But parts include amplitude, which are found in both, crests and troughs, which are in your transverse waves, and then compression and rarefactions, which are in your longitudinal waves. The electromagnetic spectrum and energy, what you guys need to know about that is increasing in your frequencies because of the energy that you put in. So if you look at your electromagnetic spectrum, It varies in wavelength and frequency, and there's only a small part of that electromagnetic spectrum that we can actually see in visible light. And that's where we can see our colors and things. Light waves and sound waves. So light and sound energy both travel in waves. That's why we talk about it more in this waves unit. They do have some similarities in how they behave in relation to reflection, refraction, absorption, and diffraction. So with sound, that's why you have echoes in an empty room, because when you talk, your sound waves are bouncing off the walls and coming back to you. Same with light. When you use lenses, those convex and concave lenses, you can get some reflection and some refraction. Remember, refraction takes that white light and splits it, bends the light, and that's when you can see all the colors of the rainbow. There's speed of a wave in terms of density. So the more dense a medium is, the faster sound travels through it. And then wave properties and energy. So frequency and wavelength. The more energy you're putting into a wave, the higher the frequency and the shorter the wavelength, which sounds like it doesn't make sense, but frequency is, the amount of waves that you have in a single period. So if you're adding more energy, you're going to have more waves in a shorter period of time, and the distance between each crest or each trough is going to be shorter, which is going to be your wavelength. Magnetism. You guys just went over this not too long ago as well. So magnetism deals with fields. So you've got magnetic, gravitational, electric fields. They always exist between objects, even if they're not in direct contact with each other. Conductors and insulators. Conductors assist in the flow of electricity, while insulators do not. And the strength of electric and magnetic forces. So you guys talked about electromagnetics or electromagnets. You can make them stronger if you add more coil wire. But you can decrease the distance between the objects. That's going to increase the force. Also, the number or size of batteries, and a varying size of iron core is going to create a higher magnetic force. So now what? Okay, so that was a little longer than 5 minutes. I apologize. But what you guys need to do at this point is just continue going back through previous notes, previous tests, making sure you're really studying and understanding these concepts. I went through them very fast. Watching this video is in no way going to make you 100% prepared for this test. It's going to hopefully jog your memory, make you guys remember what we've done in the past. And if there's something that you watch today and you're thinking, hey, I don't really remember that, come see one of the science teachers. We can give you something to practice with. We're going to continue to practice and continue to study in class. But I know if you guys really put your mind to it, this is going to be a breeze for you, okay? So just let us know if you have any questions, and I know you guys are going to do great. So enjoy the rest of your week. Have a safe spring break, and I hope you enjoyed your first episode of Science in a Sweater.
All right, that's all we have. So if you found this video helpful, don't forget to like, share, and subscribe. Just kidding. I don't care about that stuff.
Hey, that's my catchphrase.
Shoot, peace out, 8th grade. Don't forget to study.